Comparing data using median and interquartile range. Now in this part of the video, we'll be talking about the following. Now actually when we compare median and interquartile range, these are mainly for the types of graph or data that involves either a cumulative frequency graph where we can read the median, upper quartile and lower quartile, or a box and whiskers plot where we can see also the median, upper quartile, lower quartile, and the maximum and minimum. Now, what do we use when we compare performance? So for example, like we want to have a clinic waiting times for two clinic. Clinic A is 15 minutes and the median waiting time for clinic B is, let's say, 30 minutes. So how do I know which clinic has a better waiting time? So for comparing performances, we will always use the median. We'll compare the median. But however, how do we compare the median? It depends on the question. If the question is talking about waiting time, so the smaller the median, the better. If the question is talking about the number of marks that you get, the higher the marks, the better. So when you compare the performance, you need to state the evidence. So you need to write out comparisons of values. Okay, so let's say median of clinic A equals to 20 minutes, it's lesser than median of clinic B, 30 minutes. So therefore, then you write a conclusion. Okay. But now, on the other hand, we also have comparing a spread. Now, what do we use when we compare spread of data? Here, we will use the interquartile range. Now, what do we know about range? Interquartile range, or even the range itself, tells me the spread of data. So, a larger interquartile range tells you that there is a larger spread. And what can we know from data if it has a larger spread? What do we know about the consistency? So if you have a data with larger spread, the numbers are all spread up together, so the performance will be less consistent. On the other hand, if I were to have a smaller interquartile range, there will be a smaller spread. So what do we know about the consistency if I have a smaller spread? So that means this data with all the numbers all gathered together very near each other, that means this data will be more consistent. Okay, up next, let us look at some of the effects of median and interquartile range on the shape of cumulative frequency graph. Let us consider the following cumulative frequency curve. So if let's say this cumulative frequency curve has this median, what will happen to a cumulative frequency curve if they have a larger median? That means the median increases. So what we can have is when the median increases, the median need to shift, become a larger number, but this number of frequency here still stays the same, just that you will come to a point where you have a larger median. So in this case, this one will have a higher median. And what happens to the whole graph? Now, they did not say that the gradient or whatever changes, so only the median changes. So in this case, the whole graph will now shift to the right hand side. So we know that the higher the median, the graph will shift to the right hand side. Okay, so what happens now if I were to have a lower median? So let's say the median now, the cumulative frequency value, the number stays the same, but now it's a lower median over here. So this is a lower median, smaller median. Okay, then the graph, the gradient still stays the same, doesn't change, but then now it shifts over to the left hand side. So now we know that for a smaller median, the graph will shift to the left hand side. Okay, now next, let's consider the interquartile range. Okay, the effect of interquartile range on a cumulative frequency graph. Okay, I should shift this a little bit over here. Now let's consider the interquartile range. How does it affect the shape of a cumulative frequency curve? Now we know that interquartile range is found by taking the upper quartile minus the lower quartile. right? So now if I were to have a curve, okay, with the same median, but it has a smaller interquartile range, so that means this number over here is going to become smaller, not as wide as this. So what will happen? And it passes through the same median, so the same middle point, but now at this number here, it has a smaller range, okay, and at the lower quartile here, it has a smaller range. Okay, what will happen to the shape of the graph? It will look like something like this. You'll pass through the smaller interquartile range, and then a smaller upper quartile number, but remains at the same. So from here we can see that originally my gradient of the graph look something like, probably like this, originally was something like that, and now my gradient of the graph changes to something to pass through the same middle point, but it is like this. So when we have a smaller interquartile range, the gradient actually became steeper. So right, when you have smaller interquartile range, the gradient becomes steeper. But what happens now if I were to have a larger interquartile range? A larger interquartile range, where, for example, if it passes through the same median, but now we have the same frequency, but it passes through a larger upper quartile, and then maybe a smaller lower quartile. Okay, so my curve will now passes through these points. Okay, and it'll look something probably like that. Not very nice, but what do you notice? Originally my graph, okay, was something like that with this slope. Now it became something like this across. So in this case, what do you notice about the slope or the gradient? So the gradient actually became less steep. Okay, so we'll know that for a larger interquartile range, the gradient is less steep, so hence it will have a flatter gradient. Now this is the general summary of comparing data using median and interquartile range. Bear in mind, median and interquartile range are usually available for cumulative frequency graph and box and whiskers plots. Please do not mix them up with group frequency table, where you calculate the mean and standard deviation. The questions are slightly different and the interpretation will also be different. I hope you have learned something for this part of the chapter. See ya!